Let us talk something very basics of official statistics. I mean very basics, and I'd like to illustrate with certain stories, episodes, which would probably highlight my idea of what I want to convey to you. The first story I will tell you about, this is an event I learned from my teacher when I was a student. This is about Sir Ronald Fisher. Sir Ronald Fisher was teaching a course in Cambridge, maybe 1925, 1930, almost 100 years back. And he was teaching them the notion of correlation coefficient. Now you probably learn or you have already learned this notion of correlation coefficient. We have two attributes and we want to study how were they associated. This is very, very important. Something like very trivial, like if you have more area under cultivation for wheat, you expect to be more wheat production. If you have less rainfall during a vegetable season, you have less output of vegetables. For example, if you see a lot of sunshine, then the amount of rain should be less. So this is the notion of correlation. So in my first case or second case, area under cultivation and production of wheat, amount of rainfall and production of vegetable, or the amount, these two are what I say positively correlated. That means if one increases, the other also increases. But the other one I say negatively correlated. If the sunshine is more, the rainfall becomes less. So this is the notion, the association of these two attributes. And well, there are mathematical formulas, mathematical treatments. Maybe you will probably find it from some other lecture or some other book, or maybe you already know it. But the crux is that from this algebraic formula we can derive many properties. Something like it lies between -1 to +1. So -1 or +1 means that if I know one attribute, I understand the other attribute completely. Say for example, if I know some person's monthly income, maybe or may not be, maybe I can understand his pattern of expenditure on say entertainment. So these are very highly correlated. If you have really more income, you should spend more money on entertainment. Now +1 means it's completely known. -1 means it's also completely known, but it's the other way. And 0 means seemingly they have no relationship. Something like the rainfall and whether how much water I drink a day. I would not expect any correlation between these two. I call it 0. So this way Sir Fisher explained the concept, the algebra, formula, interpretation, blah blah blah. And then comes the main part of the story. He tells his students that you should go to the library and collect some data. What is the data? So you should look into the bulletin of the UK government of different ministries, ministries, I think they call it ministries, USA call it departments, the ministries. One group was, so the students were divided in two groups. One group was asked to look into the bulletins of the Ministry of Commerce, and they should note down for last 30 years for each quarter the amount of apple exported from UK. The other group was asked to look into the bulletins of the Ministry of Social Welfare and Justice, and they should also copy down or collect the data on how many divorces were recorded in that quarter in UK. So they collect this data, so they bring it back to the class and then Sir Fisher makes a table. Quarter 1, the amount of apple export, the number of recorded divorces. Quarter 2, amount of apple export and number of recorded divorces. Likewise, there are 120 data points. So he computes the correlation coefficient. and it turns out to be almost minus 0.9. Now, if I go by our usual statistical understanding of this data, the inference would have been that if you have to reduce the number of divorces, then you must increase the export of apple. And nothing could be funnier than that, right? This is absolutely useless, because you have numbers, you have formula, you put something, something will be computed, something will come out. So here something came out, and interpreting this would be very dangerous, could be misleading, could give the statisticians a bad name. So what is the problem here? We didn't understand the domain. We didn't understand the attribute. We understand the relationship between these two attributes. That apple export and divorces have nothing to do with each other. If we knew this one, if we understood this one from the domain knowledge or from the experts, then we would not do any statistical analysis. We would not do that, because statistical analysis will give you something which could be very misleading. This is called spurious correlation. This is called understanding the effect, the causal effect, and this causal effect should be understood very carefully before you do any kind of correlation analysis. Now this is true for any application. So in official statistics, when you want to do certain study of relationship between attributes, and you must first be sure that the attributes are associated in some sense. We should be able to justify this from another angle, from the domain knowledge, and if we do not do it, we never ever do such statistical analysis. So this is one very important lesson, that we have to understand the domain before we publish any data, before we do any analysis. Just data itself is not really meaningful. Okay, there are other cases. What is data? Data is a very, I would say, very vague or difficult concept. No, I think the way we try to understand, even in a country, in a state, in a district, we usually try to understand the society, understand the function of the government, understand so on and so forth. So we should have certain idea about what is that we are trying to understand, and accordingly we have to first decide what kind of data would be probably required. There is another way of doing it also. There could be plenty of data, abundance of data. People, data was collected, it is available, but people don't know what to do with them. So we try to analyze that, we try to do data mining, try to come to some inference. This is another approach. Abundance of data, and we try to get some meaning out of it. But the other thing could be, we want to study certain things, we want to verify certain hypotheses, certain ideas about the population, the society, the government. Then what would be relevant data? I think that is very challenging. So this is what I call, what you normally call a design of experiments, or it could be a sample survey one, where from the data actually emerges. Now I will give you again another story, again due to Sir Ronald Fisher. This is a very, very important story to understand what is data and what is meant by generating data. So the story goes like this. Sir Fisher has gone to one of his friend's house, and the British custom is to offer a cup of tea and a few cookies, what we call biscuits here. In fact, you know that the tea habit has come to India from British, and that time British, also like our Indians, used to drink tea with milk and sugar. And how you make the tea? The British style was that you boil the water, and then you put the tea leaf in the boiled water, brew it, then filter it. Now in some cases, people who put sugar while brewing it, and then filter it, and then mix milk. And in some other case, they would first filter it without sugar. They will, I think, brew it without sugar, filter it, and then mix sugar and milk later on. Now what are these two methods? There is only one difference, is that when do we add the sugar, while brewing or after brewing. So let me call this while brewing my choice B and after brewing my choice A. There are two choices. So just as a passing remark, Sir Fisher asked the lady of the house, his friend's wife, ma'am, you could put the sugar while brewing or you could add the sugar after filtering. Now what do you do? And then she said, I always add sugar after filtering. And then he said, any particular reason? And she said, otherwise the tea tastes horrible. Now this is what shook Sir Fisher, and he asked the simple question. Now, if I give you a cup of tea, can you find out or can you tell me whether the sugar was added while brewing or after brewing? He said, of course, I'll just take one sip and I'll get it immediately. Now this is a conviction or a belief of the lady. So this is what I was referring to when you are looking for a societal event, a government event, its effects, its whereabouts. You have certain ideas, certain beliefs, certain hypotheses. And according to the hypothesis, you have to think what could be relevant data to validate or reject this particular belief. So in this case, the belief is that the lady can distinguish between the two kinds of tea preparation, one putting the sugar while brewing, other putting the sugar after filtering. Now, we want to validate this or reject this one. So Sir Fisher thinks of a game, or I call it an experiment. He says, okay madam, if your belief is so, let's play a game and let's validate it. Maybe you are right, but let's validate it. She said, yes, you do whatever you want to do. I am ready to cooperate with you. Then he said, okay, you please make 2 pots of tea. In the first pot, you add sugar while brewing. In the other pot, you put the tea where sugar was added after filtering. And milk anyways added later on. So you please bring those 2 pots to me. So he tells that and she agrees. So she gets 2 pots of tea, preparation in 2 different ways, 1 and 2. And then Sir Fisher says, can you get me 10 cups? So she gives 10 cups. And he has some chalk. So at the bottom of 5 cups, he writes 1, 1, 1, 1, 1. That means this is from the first procedure. And he says, madam, pour the type 1, the number 1 tea into these 5 cups. So he does it. And in the other 5 cups at the bottom, he writes 2, 2, 2, 2, 2, and then requests the madam to pour tea into these cups from the other pot. My method 2. She does that. So on the table, this side there are 5 cups, These 5 cups have got tea from method 1. These 5 cups are tea from method 2. Then what he does, the essentiality of statistics, he randomizes. He just puts these cups this way, that way, here, there, so that it's kind of randomized and no one can see the bottom of the cup. So now you don't know if I give you a cup whether this is from method 1 or method 2. Now he sets the rule. Madam, the rule is that you take each cup at a time. Take 1, 2, 3, how many sips you want to take, and then you would say, is this from method 1 or from method 2? And you do it for all the cups. And she says, oh, this is very simple, I will just tell all the 10, I will just one sip and I will take all the 10 correctly. He said, but anyway, this is, probably you can tell all the correctly, but we are statisticians, we want to make sure and also we allow you an error. Now, if you have no idea of how to distinguish between these two varieties of tea or methods of tea, then how many could you tell correct? Well, easily 5, because I could just say all of them are from method 1. And then I will be correct in 5 many cases. So telling 5 correctly gives me no information as to whether the lady can distinguish between these two methods of tea preparation, right? And if you are correct with your conviction, then you should be able to tell all the 10 correctly. So let me allow you 10-20% error. So I say okay, even if you tell 9 correctly, I would accept that you have the capability of distinguishing between these two varieties. So the rule of the game is that you test this 10 cups of tea, tell it's method 1 or method 2, and if you tell 9 or 10 correctly, I will accept that your belief is true. But if you get less than 9, then you have to accept that it's just your belief, you had no reasons to have this belief. She says, oh no problem, I'll do it. Then she takes sips from all the 10 cups and tells 1, 2, 1, 2 like this, and she could tell only 7 correctly. So according to the rule of the game, she loses. And what's the inference? That she cannot really distinguish between these two methods of tea preparation. Now why I tell this story? This is because what I feel strongly in this official statistics domain, you just don't collect data from nowhere. You have to understand what is that you want to infer, what is that you want to study, what is that your conviction or beliefs are, and according to your objective of study, your conviction, your belief, you decide what are the right attributes, right variables which will be studied, for which the data will be collected. Now, if it is, say for example, your expenditure on health in each month, you could go and the thing is very simple. You just go to a household suitably chosen and then ask the household how much money did we spend. So that is the data. But in this context, you have to design the entire experiment, and then what is the data here? That yes or no. For all those 10 cups of tea, her response was yes or no. That yes or no, yes, no, yes, no. This sequence of yes or no for the 10 cups, that is the data. Okay, so I define what is my data, I define how to collect this data, so I did this entire experiment. It all evolves from certain belief about a certain phenomena, so this could be certain societal behavior, certain government functioning, attitude of citizens. So I have to understand what I want to do. Then accordingly I think we have to design something, and what is relevant data. That's one of the toughest challenge in official statistics, to decide what could be the relevant data for your particular study, for a particular inference. Then the next point comes is that how do I know this data is correct, say for example. How do you know that this is a valid data? So I'll again tell you a story. When I was in my undergraduate at ISI, we had an outstanding teacher, Professor J. Roy. He was teaching many things. We had a long practical classes, and in the classes we had to do practicals, and we had to use the facet machine. No computers that time. Well, we had computers, but as a undergraduate student, we had hardly any access to the computers. So we would do these mechanical calculating machines, these facet machines. And it was very boring, and we never enjoyed this using facet machine, heavy metallic machine, and you have to move this handle right away, this way, clockwise, anti-clockwise, and register, type. Oh, this is a nightmare for us. So one day he comes Instead, what you do, you take a square sheet where you used to write our data. It's basically a page, little more than the current A4 pages, maybe A3 pages, 50 rows and 20 columns. So we have got 50 times 20, 1000 small squares. And then he said, okay, you take a coin from your pocket or from your purse and then toss it 1000 times. Okay, and then if it is a head, write 1, if it is a tail, write 0. And once you have fill up this entire page, you can just leave. And then he leaves the class. And we looked at each other. We thought Jera is very smart. How could he be such a fool? Does he expect us that we will really toss 1000 times and then write the output when he is not there? Even if he is there, we will do 1000 tosses. And then we thought maybe he will come back. So one of our classmates just followed him, and then he came back in a minute. He says, oh no, Jera is gone. He got into a car, some original government car, and he has left. So we know that he is not coming back anymore. Very simple. So we are all very smart kids. So what we will do? We know of the 1000 tosses, there could be 500 heads, 500 tails, more or less this way, that way. So we just quickly finished a sequence of zeros and ones, 1, 0, 0, blah, 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 1000 times. In 5 minutes, we fill up this page. And we all leave. And we live for watching movies, because in our time, movies was, well, one of the, I think, the most source of entertainment. We didn't have all the internet, this computer game, blah, blah, we never had. So that's, going to movie was a lot of entertainment. Nowadays, movie theaters are gone. In fact, the movie theater where I went, they are no longer existing. So, we all ended up going to movie theater. So a week later, Professor Roy comes and tells, did you do the practical? We told, yes sir. You toss it 1000 times? Of course sir. Then he takes our output sheet back from us. And then he redistributes so that each one of us has the practical output of some other classmate of mine. So I was probably having Pantulu was probably having Mathur was probably having Indranaths, and so on and so forth. And then he asked, okay, Bimal, you have got Pantulu's output sheet, just count how many times, say he got 6 possible, 6 consecutive ones. Now, I was counting and I found none. I told, no, he didn't get a sequence of 6 ones. So, okay, it may happen. It's not that likely. So he asked, Pantulu, you have got Mathur's output. Just see how many times Mathur got 6 consecutive ones. Mathur also has none. Now the entire class moves like this, and none of us had any sequence of 6 consecutive ones. Then he said, oh, okay, this may happen, but let's do some elementary probability. Now if we toss once, what is the probability that I will get a head? Well, we say, wow, 1/2. If we toss twice, what is the probability of getting 2 heads consecutive? We say, of course, 1/4. If we do 3 tosses, all 3 heads, 1/8. Likewise, if I do 6 tosses, all 6 head, is 1/2^6, which is 1/64. So, if I look into this 1000 output sheet, if I see how many times I have a sequence of 6 consecutive tosses, I'll have 1 to 6, 2 to 7, 3 to 8, and so on and so forth. So many occurrences. All these are 6 independent tosses of a coin, hopefully unbiased. Okay. Now so I get how many such occurrences? It's about 1000 minus 5, or maybe 995 or 994, and the probability of getting 6 consecutive ones is 1/64. So how many times shall I expect to get 6 consecutive ones? Looks like something like 15 or even more. So, why didn't any of you get any occurrence? Because you did not toss. You thought, I am a fool, but actually you all are fool. I want to teach you something, now I will teach you what I will teach. So, when you think of a data, like in this case your data was the 1000 sequence of 0 1, that's your data. The data doesn't fall from heaven. There must be some underlying processes, procedures, models from which this data is emerging. You have to understand that particular process or model or procedures for generating data. You have to understand that very carefully. And once you understand that, you know what you are going to or what you are likely to expect, what you expect, what you are likely to get. And that is what is the most important thing in official statistics for data validation. So you must know that what you are studying and using the usual phenomena, what is your expected nature of this data. If it doesn't match, then naturally you would assume that this data is not really a believable data and I cannot do anything with this data. It's all fake data. Like for example, the trivial thing I think in official statistics you do, for each attribute there is a range. Suppose your age. The age, we don't expect this to be more than 100 normally. If you find certain age to be 180, you immediately know this is the wrong data. Okay, so this is understanding of the domain and the data. So what it's likely to be, or also if you see that 90% of the age of this entire this is a village is less than 10. That's not believable. So when you trying to understand the age distribution in your sample population or your village or district, you roughly know what would be the pattern of data. Like if you visit 1,000 household, you get data of some 5,000 people, and if 4,500 of them their age is less than 10, this something is not feasible. Or one age is 180 is not feasible. So you have to understand that this is what is causing some discrepancy. Likewise, I'm collecting data on say household expenditure. So normally you ask maybe what is your usual income. People normally don't like to tell that, but even if they say, well, they say we have certain income, and then you are trying to understand the expenditure pattern, and then you maybe getting asking them the questions like on food item, health expenditure, rents and stuff like that. If suddenly you see the rent is more than 50% of the total spending, then you start doubting, right? This is something not quite valid. And at some point of time you just say entertainment cost is more than even the total expenditure. Now these things are not feasible. And how do you understand this infeasibility? Because when we are trying to collect some data, we understand the attributes deeply. We know how the attribute should behave like, what the range of values the attribute should take, what kind of association they may have, and all these things must be validated by your data. So that is the first thing of once I get the data, what to do. As I told you, the first part is what data do I collect? This is very important. It depends on what I want to do with the data. So we just don't arbitrarily collect data. We have to understand the purpose. We have to understand what data would be relevant to study or fulfill my purpose. Second portion is once we have data, we have to validate. How do you know the data actually conforms to my requirement? So you have to understand the attributes, their behavior very deeply, interrelationship between the behaviors very deeply, and you have to validate your data, taking care into all these properties that we would be studying about these attributes. Now this is something where we have to collect data, we have to handle with the data. But nowadays what is happening in even the statistics domain, you don't have lots of data. Maybe you didn't intend to collect it, but there is data. These are called crowdsourced data. People voluntarily say, you look at Facebook. Okay, so people try to put the data voluntarily on the Facebook, not everybody. See, for example, I am a member of Facebook, so I don't put the data on the Facebook. Even if I am a member, I may only put data only on sports, not on movies. So this is all completely voluntary, and how many of them are participating is not known. But still, we put certain comments, certain things. These are called crowdsourced data. So we have got a huge amount of crowdsourced data. Now this did not arise out of a scientific design methodology. We didn't define what are the attributes to be collected. So if we could have done it, then our methods of analysis would have worked. So we must be learning about different methodologies, how to analyze this data. So this is not so true for if I have data which are crowdsourced. Now then do we stop or do we utilize that? No, data is gold. Data cannot be ignored. So we would very much like that the data, whatever we have, we try to utilize. So I'll talk about a specific example. Suppose there is a nowadays these landlines are not there, but in say even 20 years back there are mostly landlines. There are hardly any mobiles. So we used to have most of these telephone sets were actually manufactured by ITI. As a Indian Telephone Industries company, they would manufacture this one. And they used to get out of order, we used to go to a mechanic, we used to go to some shop, we used to get some expert in house, and they'll fix this telephone sets. And then, so if we go to these telephone repairing centers, we can probably get this ITI particular brand, this telephone sets, whether they were brought to this center, and if so, when and what was the problem, was it a minor problem, was it a major problem, and so on and so forth. So this data is already there. Now we could do the same thing because there are some private players there, some private manufacturer, they also used to do it. So what we wanted to do, say the reliability part of these telephone sets, the ones manufactured by ITI and the ones manufactured by some other private parties, which is more reliable? Well, from our experience we may probably say this is good, this is bad, but if you want to really make a study, so we want to study which one is more reliable. Now here I am not doing any study or designing or generating data. I have certain things available in the public from these centers. Now here people may not come to report to this center. I have got a few centers. They are not random samples from all the centers. Even when I go to this center, not this is my own choice, or sometimes I get very so bored with this the mobile with this landline. I just almost throw it and get a new set. So we don't have this data. But how do you have data? Some optional data that it was wrong. It was not functioning properly. I came to the center and it was fixed, and this is probably a minor one or maybe a major fault. So this is the data. So how do we use this data? So here we worked at ISI at length on how to handle this crowdsourced data. So here I will just tell you one simple way that we thought could be done. Now, say for example, I take a timeline when all these faults were reported. Okay, say for example, for the ITI telephone sets, I get a timeline that these faults were reported in my selected or my chosen, not randomly, my chosen service centers. And I know that this is a major type or minor type. So I have a timeline, I put major, minor, I do a timeline, then major, then again minor, everything, major, and so on and so forth. So I have this timeline and the record of these faults. So I have accordingly say probably for some private company. I think Beetle, there is one company called Beetle. So they are a telephone product. And we also look at this one. Now how do we make a sense out of this data? This is data, this is crowdsourced data. How do I decide which one is more reliable? ITI or the Beetle? So what we proposed is that let's look into the major faults for each of the cases and see how much time or how many minor faults were reported between two major faults. Suppose for this one, I see on an average between two major faults, I had only 3 minor faults reported, and the other one I find that between two major faults I have 25 minor faults. Which one is more reliable? I try to argue that the one who is having more minor faults between two major faults reported is probably more reliable than the ones where major faults come more often. So we define something notion called sparsity of these major faults. Whichever is more sparse, we think that one is probably a better one. Now this is one way of analyzing this crowdsourced data. And in official statistics, the data is coming with abundance. And now what we do, and I will call all of them are basically crowdsourced data. It didn't come from a thoughtful design. And but then what do? We must analyze that too. And that needs a very different technique, different methodology, which is not the classical ones, could be even debatable, arguable, but we have to do something. My example sets a motion that we can possibly do something. Okay, let me stop here, and I hope you understand the notions. Data, attribute, the association, the inference that we want to do, and what we can do even if the data validity, very important. And even if we do not have structured data, we have just crowdsourced data, then also we should be able to make meaning out of it, and which would help the society, government at large. Thank you.